Just to add a little bit more to Howard's introduction, so ManySecured is a collaborative project, and its subject matter is collaborative analytics. By that, one of our primary objectives, as we'll explain in a lot more depth in a minute, is how do we build a wider international industrial collaboration that makes not just the underlying technology of routers, but the information sharing collaboration worldwide, across the industry. And to that end, although ManySecured started as a UKRI funded project, the SIG that now exists in IoTSF is intended to be a long-lasting, sustaining thing, and that is the thing in which we hope to get wider engagement. So in terms of the actual agenda, I'll just shuffle things around a bit in light of the attendees. So it will all be fairly fluid, but in the morning, basically, I'm probably going to talk for about 50 minutes to give you a little bit of background. So some people in the audience have some of the background, but a lot of people it's news. But I think it'd be useful to give the wider context and look at the bigger problems we're trying to solve. And then after the break, we'll start to go and get more deeper into the technology and explain exactly what it is we're building and how it all fits together. And then I will then move on to Steve from Oxford, who will then give some very concrete sort of like use cases around how we use this in terms of analytics. And then after lunch, I think what we'll then do is Alexandru, who works in nquiringMinds, will give a bit of introduction to the very low level technology that sits in the router. We'll do probably a very short step through sort of like on stage in terms of how the tools and how they fit together. But I think after that point it will become very more intimate, fluid, one-to-one, maybe moving into the back room where the devices physically are. And for those people, there's quite a few of us here, so there's enough of us to sort of share around. And then you can get some proper hands-on experience and dive deeper into technology if you so desire. But in terms of sort of like setting the scenes and for today, first thing is I've got slides, but I much prefer to be interrupted. So if you've got questions, I think it's much more useful because if I'm saying something and you don't understand it or want to know more information, then I dare say somebody else does. So I think that's a much more productive use of time. Apart from that, me talking for 50 minutes solid straight is quite exhausting. In terms of what you're going to see today, I mean, the whole culture of ManySecured is very much embracing the working in open. So some of the stuff that you see is, in some cases, a little bit rough and ready. It's not a polished product. It is open source activity, open source standards. Hang on one second. I've got a horrible feeling. That's fine. How do you stop it? I have to do every slide in 40 seconds. That got me. I was doing a presentation. I don't know, John, whether you noticed when it was in my
I did.
And I had to keep putting it back. Right, so all the stuff that you'll see in terms of the specs, the open source code, it's the efforts of the community, but we don't have a massive sort of like quality control release procedure in place because we want to engage the wider community so they can actually influence the technology as it's happening. And as such, we're very open to criticism. It's only through criticism it's going to improve. So don't hold back if you don't understand stuff and feel things that can be improved. And fundamentally, in the round, what I'm going to discuss is quite ambitious. It's quite an ambitious scope. I'm trying to solve some quite big industry-wide problems. But I think I'll convince you it's entirely necessary. So maybe not every single bit of the piece of the technology we developed will find a place long term, but I think some of it will, and it will fit into some of the other industry initiatives that are evolving around it. But just before I jump into the substance of the presentation, just do a few intros, just so you can put names to faces. So me, I think Ian's already introduced. Ashley from nquiringMinds is there. There's one of the software engineers. I'm Craig, after. John over there. Anthony, Toby, and me. So all the inquiringMinds people over there, if you want to meet them afterwards, Steve is one representative from Oxford University, over there. And then on the IoT side, so Howard, got Michael, gone over there. Ian, I think, I'll talk a little bit about what he's doing at the moment. We've got John over here.
I'll just say that you've spelled my name wrong, but it's okay because I spelled your name wrong before. Sorry.
Sorry about that. And then Angela's been helping us sort of set up for today. So hopefully that helps you with some names and faces. So, right, let's start with the basics. So what problem are we solving? So I normally have a load of slides in there about how bad the IoT security problem is. I'm assuming I'm preaching to them first here, so I'm not going to regurgitate all that stuff. But fundamentally, there's a lot of stuff out there. It's not very well secured. It's based on very cheap hardware. And the biggest problem, that we'll come back to in a minute, they're not going away. They're not going away soon because some of the devices, let's say this one here, I don't know what, it's an IoT device, it's internet connected. I don't know what security is built in, but I'm pretty sure someone's not going to chuck it in the bin if somebody just exposes a vulnerability on it. So that's underlying the problem we're solving. That is the whole reason of existence for the Internet Security Foundation. Within the ManySecured SIG, we are taking a very specific angle on it, which is we are trying to build the enablers, so the industrial standards, that will help us detect IoT vulnerabilities and then protect against vulnerabilities. And that sort of like breaks down as fine. So part of the approach, so take a step back. If you accept the fact there are vulnerable IoT devices out there, other than disabling them, the only thing that you can do is spot it to detect it. And to spot it and detect it, the only real place you can do it is the gateway or the router. And if you want to do it at scale, if you want to solve the underlying problem, you need to reduce the barrier to entry to gathering that data. Because as it stands at the moment, if every single router vendor has a different set of methods for accessing information, it means all of the information silos and all the risk is hidden from each other. But as like someone with a primarily sort of like AI background, what I need I need data. I need lots of data at scale to pick up the signal, to spot where the problems are. So, in terms of is it still so how do you gather that data? So basically you put an interoperability layer in there, and we'll talk in detail about how we do that. And so that allows the data to be pulled off the router locally. You've then got the question of, so how does that data then get shared between different entities, different agents, different stakeholders? And all of that is a necessary prerequisite to essentially spot the anomalies. As I say, unless you're gathering that data together, it's not going to happen. And part of the detection problem, or part of solving the detection problem, is working how practically you can share that intelligence. So there's a lot of bullet points there, and they're all sort of like stepping stones. But the technology that we're going to talk this afternoon is all intended to help solve all of these aspects. So that's the detect side. So I've spotted something. So what are you going to do about it? Well, essentially, there's two layers of protection, or two aspects of protection that we're looking at ManySecured. There's what I could call the sort of best practice layer, which is how do you make the thing more solid? Right. So the router itself is vulnerable. I'll talk a little bit more about why it's vulnerable in a minute. So we've basically got to raise the game. Right? We basically need to do things at the router that make it less likely that can be attacked. And what does that consist of? It consists of things like developing best practice, which is something that Ian's principally been responsible for, which is the more classic sort of like high-level security requirements and compliance statements and assurance framework, etc. There is work to be done in terms of protecting some of the interfaces, and I'll talk briefly about those a little bit later. Some of the interfaces on gateways are fundamentally insecure at a quite frightening level. And then there's the three hygiene factors, which to a serious security expert, you would say are absolutely necessary. You need secure boot, right? And if you don't have secure boot, you can't have secure storage. If you can't have secure storage, you can't encrypt something. And there's some other activities we're also doing in terms of secure processing. As I say, everybody academically knows these are necessary. I challenge anyone to point me at sort of like routers or IoT devices at scale that implementing any of that. So part of what we're doing is just reducing the barrier of entry and making this more pervasive so we've got more solid foundations. So that's the one side of protect, which is the hygiene factor. The other side of protect is the inverse of the detect. So once I've spotted something fishy on my network, what do I do about it? And there's a very specific interface that we're defining that's creating another one of these interoperable driver layers that's supposed to, well, it will be and can be implemented on routers. And fundamentally, it's then allowing the intelligence in the system, whatever that might be, to essentially do device management, network segmentation to save devices. So that, as a scoping statement, detect the anomalies, protect the interfaces, and then implement sort of dynamic protections is fundamentally what we're trying to do. Now, there are certain sort of assumptions built into our approach, and it's probably worth teasing them apart because you need to understand the assumptions to understand why we're building it the way we're building it. Now, the first is, I think I've sort of touched on this already. Why the router? Well, by any empirical measure, the router is the most attacked device. You can pull off whatever news article you like to this extent. I've just pulled up the semantic one. But by their analysis, 75% of all router attacks were, all IoT attacks were on the router itself. So that's your data point. But then underlying that, there are some more fundamental reasons. So, as I said, statistically, they're the biggest attack target. The second issue is it's very low. If you're creating an attack, a network-based attack is very low cost. Right? You can spin it up really, really quickly, and from pretty much anywhere on the globe. It's very different to sort of like going in the back of a PCB and sort of like playing with silicon bits and that type of thing. Network-based attacks are low cost, geographically initiated, and essentially just scale incredibly quickly. So those are sort of like three reasons why we need to sort of focus on the router in terms of its impact. But another reason the router is so important, implicitly, it is your line of defence. The router is it's the forward-facing part of your personal network. It's implementing your NATs and your firewalls or whatever. So, as an attacker, what do? First, you take defences down. So, so that's another reason. And probably, I should remember these now. The sixth one, it is probably the most pernicious of the attack vectors. Because if you do compromise a router, the reason you use the router to defend is because it can see everything and it can do a lot. But the reason it's so dangerous when you attack it is you can see everything and you can do a lot. So, as in terms of if I am an attacker, a malicious attacker, and I want to have maximum impact, you go for the router because it just not only can you see everything on that internal network, you then got a host to then issue these massively scalable network attacks as well. So those are sort of like the negative sides of why the router. The positive sides are, well, if I implement my protection route, I can see stuff. So I've got the framework on which I can start to build protection mechanisms. But then finally, and probably as importantly, I can actually do something about it. If I have implemented my protection method on the router and I've spotted something fishy going on, I can lock it down, I can quarantine it, I can disable it, etc. So I've got a method of addressing the issue. So in terms of what it is we're actually doing, there are 5 working groups in ManySecured currently. There's the G search, which I'm not going to talk about today, but if you do want to talk about it, talk to Ian there, who knows the stuff inside and out and is developing it. I think it's a very worthwhile activity, and I think hopefully moving forward will become some form of assurance framework for users generally. But this is dealing with all the sort of like the good security best practices needed to raise the bar. We have another area called SUIF, Secure Usable Internet Browser. That covers a very specific problem. We'll touch on it on today, but that's not going to be my area of focus. And then the next sort of like three come as a triple. So it's they used to be called Net1, Netcom. We changed the names recently. There's an area called D3 events, which is basically looking at the interoperable low-level networking events that can be used for basic analytics. DCON, which is the interface for doing the containment or the prevent part of the cycle that I mentioned earlier, and then sort of like the heart of the system, and what we'll talk a lot about today is the D3, the distributed device descriptors, which are essentially the method by which we share intelligence in a very sort of flexible and interoperable way. Right, so. I now sort of want to go back to my theme of what are some of the underlying assumptions behind what it is that we're doing. And these are really statements of reality about IoT and networking that you have to factor in when you're sort of like developing a solution. Now the first of which is the IoT problem is a heterogeneous problem. It's a heterogeneous networking problem. And what I mean by that, I mean just thinking in my own home. I have one primary router, the ADSL router, Virgin or whatever, which has got a Wi-Fi. I've got about 2 or 3 Wi-Fi extenders, which have networking capability in their own right. So already I've got 3 or 4 networking devices in my own home just dealing with IP. Now, I happen to have 4 Amazon Echo devices in my home. Not because I like talking to it, it's just they're really cheap speakers. But inside that Amazon Echo, you also have a Zigbee router, and I think shortly they're going to start enabling the LoRa router. So you've got 3 physical different networking types in a typical person's home who just bought in a standard sort of device. And that is just the tip of the iceberg of the IoT security problem, because you need to be able to ideally detect and protect on all of those interfaces. And as you probably know, Zigbee and sort of like LoRa are not innately IP networking technologies. So there's a whole different class of techniques that you need to use, and the ability to aggregate information over this, which is fundamentally the challenge that's being addressed. I think this is a diagram I created about 2 years ago, and I probably need to put it on the website and document it properly. But this is sort of like just gives you a feel of the complexity of an IoT network. I'm going to try and do some 40 seconds. So this is your main router, and what have you got in there? You've got a modem, you've got your firewall, you've got your DNS capability, your DHCP, and IP routing. Then you've got these classes of devices which are called extenders. There could be home plug devices, there could be Wi-Fi routers that may or may not duplicate some of this. Sometimes you duplicate the DHCP and DNS of those routers, sometimes you don't. That really makes it complicated even before you start. You've then got these things that we call protocol bridges. And I think you're going to see more and more of these, but I mean a Google Home device, an Echo device, a SmartThings hub, a Signify light bulb hub is also one of these. And to some extent, logically, even your mobile phone is one of these, because you might have an intelligent scale that connects via Bluetooth to your phone, and then your phone backports through Wi-Fi. So you've got a whole plethora of sort of protocols down here, which are going through one of these protocol bridges, and then the traffic's moving up into the cloud. And on the IoT, we've sort of like classified everything into IP-based IoT devices and non-IP IoT devices. Now, just for scoping, almost everything we've done in ManySecured to date is just looking at the IP layer, because you've got to bite off one chunk at a time. Most of the technologies can be expanded. and we have done some proof of concepts for Allott and Zigbee. But later on this afternoon, when you go and see some of these devices, essentially what you're going to see is you're going to see some of these that have been augmented with the security technology, and then I've got a bag full of IoT devices we can play with. I don't know if anyone has bought any of their own, but they can feel free to try them out there. But that is essentially just an indicative scoping statement that expands on the complexity of the problem.
Sorry.
Sure.
Down the bottom right-hand corner, is that meant to be remote user apps?
Yeah, sorry. Yeah, remotes. Yeah. So basically, what I've divvied it up into. So if you've got a user app, you've generally got like a PC app. You've got like your phone or your tablet, and there may be you've got web user apps, which is a whole interesting class in itself that I will touch on in a minute. But then you've got the remote ones. Now the interesting thing is, often as a user, you don't know whether you're in that mode or that mode. You don't know whether the traffic is. You could be sat in your lounge, turning the lights on, and you don't know whether the traffic's going up here into China and back down again, or whether it's going on the remote network. And that is just a taste of some of the complexity behind the problems that we're dealing with here. But yeah, it's not the reason. Right, other sort of backgrounds, and I think I'll put this in red because to some extent this requirement on its own drives probably 50% of the functionality we're building into ManySecured. And it's to that point that I started right at the start. Our challenge is addressing the legacy problem. Right? There's loads of emergent sort of technologies coming along that can paint a picture of a future world where if every one of your IoT devices has got this interface in and you've got these services.
Can I ask a question?
Sure.
So then this is driven by a free market economy, is that right?
Yeah, well, yeah. I think
So is there an alternative to a free market economy?
I'm sure I'll get the question.
Okay, so for example, let's say for example in Russia, would they have the same issues that we have in Europe? Or can actually control what's happening?
Well, in essence, yes. Yeah.
So if it's not a relevant question, ignore it.
No. I don't think I understand the question.
Okay, sorry.
I think I can translate.
Because
Sure, go on.
it's geographically and subgeographically. And you can claim on some continent or some major subgeographical areas, they are at least not worldwide attacks, so to speak, but the Russians themselves, even though they have placed the control of internet traffic, have completely the same problems, of course, because they rely on
So
same architecture.
they can't control it.
Yeah. So you build on these technologies and have these architectures, you will have these problems.
Okay, so
So maybe I can translate it differently, and you can tell me if I got it right. Most of all the technologies that he spoke about rely on voluntary adherence to standards, where the standards don't have quite the force of law, but the manufacturers mostly behave as if they do. So if you don't do IPv4 correctly, then the consequences that you don't communicate, and so there's an intense pressure for everyone to conform to the specifications.
Yeah.
However, because it's a voluntary standard and there's no acceptance testing, there is innovation all around the edges, and that's where everyone makes their money, is in that innovation. And of course, then there's the edges a little bit fuzzy. And the problem is that a lot of the details of the security are in those fuzzy parts. And in a number of Western countries, we do have regulations on certain things, and we're trying to, in IETSF, and trying to enforce more and higher things and doing acceptance testing. But in places like China, where you'd think that the state would have a really strong hammer to say, thou shalt do something or you shall go to jail, the exact opposite happens. They don't even enforce the voluntary standards that we would consider mandatory. And they say, oh, no, those are Western stupid ideals. we'll just do our own thing because we're China.
Yeah.
And so the IoT situation in China is significantly worse because they have huge internal markets that they don't export,
Sure.
where they have a captive audience who have no choice but to buy that manufacturer's thing, and so they don't even care if they interoperate. Whereas if you sell it here and it doesn't work, we bring it back to the Tesco, and Tesco, winds up with, equipment on the floor, right?
Is that the question you're asking?
It is, yeah.
Okay. I mean, so basically, what I'm saying, there are lots of emerging standards, which Michael's talking about, which people may or may not adhere to. Max is probably one of the principal ones to solve some of the problems. What I'm saying is, there are light bulbs to TVs to speakers that were bought 5 years ago and aren't getting chucked through the skip for about another 15. And the challenge, the quite ambitious challenge we're trying to address in ManySecured is what defences can we put in place that make protecting against these threats a bit more viable.
So just a question or clarification. I think your focus is on home technology, smart homes, or is it?
Most of the examples that I will give you here will be about home technology because it's usually easier to communicate. However, we are working on industrial use cases. We are working on enterprise use cases. In fact, Steve's going to be talking about the enterprise use cases in a bit, as well as some of the stuff that we're talking about. We're actually trying to put on some private 5G. So the underlying approaches, I hope, are scalable. It should be scalable, but actually, when a lot of the defensive methods that we're building up, actually, as you'll see, it's all about building up databases. So you need to do that in a more siloed.
No, that's fine. I was just wondering because your approach is on, widely, like you mentioned, on router, right?
Yeah.
Security hardening of the router or vetting or standardization and different things. Is it comparable to conventional enterprise security where you still, have a central point, be it a firewall or any of the network system?
I think the difference is the way that you'll see this in the culture, the way we're defining both the interfaces and the way the databases that can be developed. There's less of an assumption of an absolute top-down control. Because the thing is, an enterprise traditional enterprises are always solidly locked and always have been. I mean, I think I'll touch on this subject when we touch upon zero trust. They're finding it's impossible to maintain that. But then as you move to the consumer space, it's just, there is no. So we've tried to embrace a much more distributed ethos in terms of how we're building it up. But the underlying architecture in terms of sort of like control, that there will be some analogies, definitely.
So one of the key things in some of the standards is we distinguish between networks that are professionally managed, enterprises, ISPs, governments, whatever, and those that are, call it, unprofessionally managed, okay, or professionally unmanaged, I don't know. And so that includes the home, but more specifically, and the more concerning maybe, is that includes your hairdresser and the pub, and a whole bunch of other places where you see home technology deployed because that's what you have. But one of the differences is that the enterprise, as you just said, enterprise is this top-down notion, and they believe they own all the equipment, and they believe that any privacy concerns are their own, and they make the decision. And you may think in your home, I have all the privacy control and concerns, and my kids have no rights.
Yeah.
Okay, and that may be true. But go to the pub, and then you ask, wait, who gets to decide if my devices are tracked and who doesn't? Does the pub owner have that right? Probably not. It's probably a public space. So you get into this kind of, tension where maybe the technology is actually easy. If we assume that we give our kids some rights, then that same technology gives the pub patrons some rights for privacy.
And it's not about rights, it's about control. You can give someone as many rights as you want.
Yes.
You need to control those rights.
You can decide whether or not, you get to decide whether they have the right to be self-determination or not
But you have to be able to control that. I can give you rights to do anything, but I can't control.
Well, right, no, I agree with you. What I'm trying to say is that when I give you access, I have to communicate that what rights I've given you, and you have to know whether you've agreed to them or not, or whether you're going to walk away and say whatever. And as I said, for your kids, they pretty much don't have that right, but they might still want to decide that, oh, well, actually, I should know what I'm, yes, I'm being monitored, I should know that I'm being monitored, right?
Going back to the enterprise issue, the other issue is it's very easy for people now to form bridges out to 4G networks and all sorts of things, which means a central point of control just doesn't work anymore. And I think it's
yeah, that's what I was wondering in terms of analogy, because if you take a router as, you know, you're focusing on monitoring network, only talking about the technical bit, right? I'm okay with vetting and you know, standardization and all that, because they have to be separate from the enterprise. But in terms of technology and monitoring network traffic, that's what, you know, conventional security looks like. Because essentially we are following specific standards, IP and all that, right? So the traffic is going to look quite similar if it's destined to an enterprise or to the home.
Yeah, we'll touch a lot bit on this sort of as we get further into the presentation. But I mean, I think the two fundamental takeaways is basically one. This isn't a greenfield problem, right? We've got to deal with the rubbish that's already out there. So what can we add to the equation to make it possible? And then two, actually this point maybe touches this in a slice, which is in the underlying assumptions of what we built, we haven't always assumed you can trust the manufacturer. And there's a number of reasons why that's the case. One, provenance, in terms of the country of origin or the particular manufacturer's got a bad reputation. And if you have a system that's totally relying on them making statements or them making public statements of intent, that's underlying like soft sounds to build your secure house on. Secondly, the reality is, especially in the consumer IoT device, those manufacturers don't last very long. The half-life of the device is longer than the half-life of the company. And I think in the next sort of 6 months or a year, I think we're going to see quite a few of those. But, you know, we still want the security to work. We don't want that device to be like a massive sort of shining sort of like hole in the system. And then there's another sort of softer point that I think will become more clear when we look at the mud stuff is actually there's a lot of the security technology solutions that are being built out there that are brilliant by design, but will only work when everybody does it. It's the classic network effect problem, the classic patch problem. What we want is a solution which can slowly build towards this more secure system.
Individual return on investment without, it's worth it for me to do it myself.
Yeah, exactly. Yeah, your trade-off doesn't want to look like an exponential curve on the negative. It's got to be at least linear. Other fundamental sort of like design requirement is we're trying to build on foundation, right? Where there is good stuff available, and I'm going to list through some of the tech. We're trying to build the D3 such that it interworks with it, so it's not a competing spec or competing standard, but embraces all of the different strands and makes it more interoperable. And then the big one is, and I'm going to go into this in quite a bit of detail in a minute, because I think it's sort of almost like a philosophical cornerstone for it, is it's basically got to work on uncertainty, right? The reality of security, and a whole load of time at the moment, is nothing is certain. Even if you've got a certificate that's signed by X, there's n number of reasons why you shouldn't actually trust it. Facts change, information is uncertain, information is subjective. So, you know, a Chinese ISP might have a different level of trust in a Chinese sensor vendor than a UK-based one. It's a totally subjective decision. And our mechanisms, our policy mechanisms and security mechanisms has to recognise that fact or that reality. And then not only can information be subjective, information can be untrustworthy. So the difference is I don't trust the intent of what you said when you said this device is X, versus actually I trusted your intent, but the mechanism by which we sent it to me is fundamentally unreliable. And there are lots of examples of that. But we want a strong reasoning framework that deals with that. And then obviously because of all of that, information is going to be conflicted. You're going to have different bits of information that are fundamentally outside each other, so we need a method of dealing with that. So that sort of brings us on to the subject of zero trust, which is one of those industry terms. I don't think I had heard about it until last year, but you're hearing it more and more. And there's a tendency to mean whatever people want it to mean, depending on who's talking. But I think there is a very strong resonance with what we're trying to do here. So I'm just going to step you through a few definitions, just to save you looking it up. So this is the Gartner one, and fundamentally, it's what they're suggesting is it's basically what they're trying to remove is the implicit trust. In a zero trust network, they're trying to avoid the assumption of trustworthiness just because it happens to be sitting on a particular network. So that's sort of like an emergent theme that comes through in all of these definitions. But it's also asking for much more fine-grained identity, context-based logical access management. So basically, think less binary, think along lots of different sort of like strands. This sort of similar definition, so it's basically advocating moving the defences from static network-based parameters, and there's no implicit trust granted to assets based solely upon their physical or to some extent logical network. So this is the classic of enterprise models sort of implicitly do this. Palo Alto quite so this is what I quite like. It's basically eliminate implicit trust and continuously validate every stage of the digital interaction. And then the O'Reilly one, again, many of the similar sort of like underlying assumptions, but then policies must be dynamically calculated from as many sources of data as possible. So that's what the different industry definitions come in. I mean, I simplify it as it's basically just don't right? Try to reduce your number of assumptions, use multiple data sources, or as many data sources that are now available, more fine-grained, and continually assess trustworthiness.
Can that be reused in other issues in life?
Well, indeed. Yeah, I mean, I'm sure it can. Of course it can.
That could be a very wide discussion.
Feel free to use it as a my wife came up with this metaphor yesterday, actually. It's basically Little Red Riding Hood, right? Little Red Riding Hood is the simplest, most intuitive way of understanding what zero trust means. Because basically what you're saying is, don't trust its grandma just because it's in grandma's house and wearing grandma's clothes. The whole story of Little Red Riding is about essentially multi-factor continuous verification based on eyes, ears, and teeth.
Multi-faction.
So an example of this. So I mentioned the suing thing earlier. This is. There's a BT in the room, so don't take offence to this. Because the same is true on Vodafone, on every other router. But, I mean, hopefully you can see what's wrong with this picture. Actually, it's not totally obvious, but basically, there's no secure padlock here. Right? When pretty much every single router that is distributed by ISPs or by IA2 router vendors, right, actually advocates that the user logs onto that device on an unencrypted browser. Which is, when you really think about it, should be quite scary, and I'm quite worried that more people aren't scared about this than they are. Because it's basically, this epitomises everything that zero trust is supposed to defend against. Because when you do this, right, it's just, should be obvious to you, anyone can sniff that password. Anyone with a moderate level of competence. The only requirement is they have access to the network. So this is the antithesis of zero trust is. What you're saying is you're trusting that person just because they have access to that network. Now, I use this as an example just because I think, to me, it very clearly reinforces why we need zero trust. It also opens up another problem, which is, okay, if I'm not going to do that, what am I going to do? Exactly. Now, I'm not going to talk about this today, but if you go to the ManySecured website, there's a whole thing on SUID, which goes into meticulous amount of detail about expounding what the actual problem is, and people like Paul and Michael and other people who have sort of like contributed to this. We don't have a fully fledged solution to it yet, but this is something that we're working towards. And just to simplify, the fundamental problem that I want to address here is how do you combine the words of web and IoT devices? I mean, it seems a bit ridiculous that the IoT cybersecurity community hasn't actually solved that problem, but they fundamentally don't work together. It's impossible to securely initiate a session from a browser to an IoT device on an internal network because of the complexities of certificate distribution and actually the emphatic guidelines that are embedded into what's called the CA browser forum to determine stuff. So a bit of a sort of distraction in that it takes us away from the main thrust of today's conversation, which is the D3. But I thought it was useful to help understand what happens when the zero trust principles aren't properly adhered.
It's probably worth pointing out that you don't even have to be on the network. You can be just sniffing the Wi-Fi and that's sufficient. Yeah. So,
and again, I think that's just,
just doing it first doesn't help.
exactly. And it's to me, it always surprises me. It's sort of the collective stupidity of cybersecurity professionals when they don't really think through the end-to-end. And I use this as an example, which is this is the ETSI, this is the EU. We talked about free markets. We are a free market, but they're constantly trying to regulate it. So these are the ETSI IoT guidelines. Specifically says communicate securely. One of the provisions, which is implicitly going to be getting written into UK law. And to me, what's interesting is the exact wording of this. Blah, 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 shall use best practice. My big issue is I've got no idea what that is. Right, so I'm quite worried about them enacting a law where I actually don't know how to do it, and where sort of like professionals here.
Well, if there's no definition, it's meaningless. You've got to define what best practice is, surely.
I think in terms of
who says what is best practice?
Well, I don't want to get the details of the legal process.
Okay.
There are people in the.
it's good to have such a definition in law because it means that the state of the asset then.
Yeah.
So you get a court and you argue it out in court.
Exactly.
Well, the way it's actually
great if you're a lawyer.
Well, it is.
Conversely, and this is what you'll find in you'll find things such as you must use this really old, awful connectivity standard, and it's because of actually putting technology in the legislation.
But is there not a word actually there that a judge or a lawyer will see immediately, and therefore the thing or the thing in the browser should actually regulate up to this, even though it's very vague?
Yeah, I mean, I'm not an expert. I've looked. Basically, the way it's going to happen in the UK might be different than happening in the EU. In the UK, we've got primary and secondary legislation. The primary legislation is quite soft and fluffy and devolves it to secondary legislation. The problem with secondary legislation is delegated to some sort of competent authority that will put in compliance methods. But I'm a detailed person. I want to know what it is because I fundamentally don't know how to solve the problem. That's the sort of like the red flag that triggers me. Okay, a little bit of distraction. I've talked about zero trust. I just got a couple of slides on trust in a more fluffy sense, which I find quite useful. Okay, so this is like a mental model I use when people start using the word trust. The word trust is bandied around quite a lot, and it means, I want to be specific because I want to understand. I think two useful tools you can use to explore that is exploring the concept trust as a transitive concept. Now, it's a technical term, transitive. It's actually got two technical meanings, both in a linguistic and a semantic sense. The interesting thing is it ticks both boxes. So syntactically, like a transitive verb versus intransitive verb. Bob plays the guitar, right? One is subject verb, one is subject verb object. The point is when you use the word trust, and I'll say the same with authenticate, and the same with authorize, and the same with author, you need to qualify it. Because I am astonished the number of times in specifications and in technical documents you don't see that well specified. And in the absence of that specification, it sort of becomes meaningless. So I think this is all sort of the fundamental of what zero trust is. Zero trust is all about qualifying what that means. I am going to allow this person to do this thing for this amount of time. Then the other aspect of trust. So transitive in the mathematical sense is basically if there's a relation between A and B and a relation between B and C, you can infer there's a relation between A and C. This is security and trust all over. Every time you see any piece of security, there are dependencies in place, and you really need to sort of think through and spot where these are to see where the problems are. And again, the inverse of that, this is part of how you actually implement a solid zero trust policy. And just a classic example of this, people will talk about, my system's authenticated. My device here is authenticated by this person here. You think through the chain of what is required to be there in the transitive sense, it'll always take you back down to actually hardware and secure thing. I mean, I won't take you through the full model, but actually, without basically secure boot and secure storage, you've got no storage keys, you can't do the encryption, therefore everything's broken. And I think it's being explicit about this in as many stages, I think it is, to me, part of what a good solid zero trust strategy is. And to some extent, I'm not going to give you the solutions to that, but I'm going to give you the tools to help express more of these steps and into dependencies between the steps. How are we doing for time?
Running behind a bit.
All right. Okay, I'll probably do a couple more slides and then I'll break. Oh, actually, no, I'll do about 4 more slides. Real world trust, who, what am I trusting them for? Is someone opting on my behalf? How long for? And unless. Because there's a lot of conditions under which that trust is broken. And I think we need to find out that explicitly. So I think we'll have coffee in a minute. I'll just do a couple more slides before we have coffee. So another topic that we're starting to use more and more in the ManySecured is the concept of cognitive security. Why? Because, how I introduced me, my background is AI. Actually, my first degree is in cognitive psychology. So I have somewhat of emotional attachment to that concept, but fundamentally, it's all about reasoning under uncertainty. So, I've just pulled out a couple of definitions. I mean, the biggest problem with using the word cognitive is IBM's been banding it around for ages. And it's somewhat, they sort of own that space, or they try to own that space. I mean, Watson seems to be slowly sort of disappearing on the horizon, or certainly it hasn't got the same vibrancy that it used to have. But I refused to let that limit my use of the word cognitive. Wikipedia will tell you there is no widely agreed definition in either academic or industry. But fundamentally, as far as I'm concerned, and this is the sense in which we're embracing it, it's basically the application of AI technology as a reasoning framework, which is patterned on human patterns of thought. And I think as we dig into the detail, I think this is quite important because the reality of reasoning about the security status thing on the network is reasoning under uncertainty, and you need some sort of like decent sort of like metaphors or computational paradigms to be able to do it. Fundamentally, it's if you go back to what zero trust is, it's not binary. Security is not black and white. It's a continuous function over time, and we need the tools to be able to do that. And as I implied on the other slides, when I'm trying to assess the trustworthiness of the device, I start. It's not just a binary decision. How can you prove you've got the private key? You want to ask, okay, what's that person trying to do? Who's doing it? How long for? What dependencies are they? What are the data sources can I use to corroborate all of those statements? And accept always the fact that things change. And so when we go into the fundamentals of the D3 framework, what you're going to see is the mechanisms by which we can express a lot of these constraints, but also express how these constraints change. So last couple of slides before coffee, which hopefully will set us up for the discussion this afternoon. This is fundamentally what it's all about, right? Fundamentally, what we're trying to build in D3 is an intelligent control group, right? So implicitly under here, there's the router, right? And what we want to be able to do is to implement a control group that can intelligently detect and protect threats. There are a couple of enablers to make that happen. There's these things that are called D3 events that I'll talk about after coffee, which is what are the messages, what's the finite set of sort of statements that I can use upon which I can make an inference. There's the smarts, the clever bit, I'll touch on in a second, but let's just treat it as a black box at the moment. And then once I've detected something, the decon, how do I do something about it? So the D3 events and the decon are enablers. So the fundamental enablers that, like a software driver, allow us to then plug in the clever stuff on multiple different types of router.
Were they called something else a few months back?
Yes, they were. They're called Netcon and Netcon. But Michael really didn't like that, so that's changed.
Netcon's not IoT spec.
I do think it works a bit better actually.
So our Netcon
goes
in the opposite direction of
the specs on the website haven't been updated.
Netcon is actually a network management.
Other people have used those terms, that was the objection.
Everybody.
It would be to write the RFC for this.
Under the smarts, right, this is where the cognitive metaphor really comes in. And there's lots of different ways you can do the
Great. I don't care.
cognitive sort of like metaphor and analogy, but this works well. So this is the sensing, this is the raw data, this is the sort of the phenomenon of what you can see in the world. In the context of networking, it's a PCAP trace or a derivative thereof. Or more specifically, this is the equivalent of the PCAP, and then the perceptual layer is actually, there's a shitload of data in PCAP, I can't possibly use that, I can't move it around. How do then I synthesize that into data which is effective and meaningful to then process? So then this is a street.
Touch sensitive screen with a positive laptop.
So so this is sort of like the sort of like the first layer of the post processing. But then you need to dump it, so you need to memorize it, because otherwise all you're seeing is the now. And when you're processing, you want to process what's happening now in terms of what happened before, and that's sort of like the fundamentals of learning. There's like an inferencing layer, which basically is the layer on which you can assemble some structure or some meaning or thing that I want to do, and then the action, that's the decon bit. That's when stuff actually happens. Then you can optionally implement a reflective process, which can run under the whole thing and sort of tune the perceptual layer, or tune what I decide to memorize, or tune how I inference. But to some extent, the thing that drives it all, and this is the fundamental of what the D3 is okay, how do I cooperate? Right? So this gives you an example of how an individual brain reasons. This is how brains work collectively. And they work collectively through language. They work collectively through the ability to express things, whether they be threats, whether they be types, whether they be expected behaviours. But if I've learned something and I want to communicate it to you, so you can do something useful, I need a language with which to be able to express that. And that is sort of the fundamental heart of what D3 is. So this is a very grandiose metaphor for describing what are actually a lot of quite simple sort of primitives, but it hopefully gives you a flavour of what we're trying to do and where it's going. So I'm hoping coffee's ready now, is it?